it's heat flow through buildings that dries them out. So if you reduce the heat flow through a building and you don't manage the moisture better, well, the moisture is going to stay in the materials longer.
Welcome to the Fine Homebuilding Pro Talk podcast, a regular discussion with building industry professionals. This is Senior Editor Patrick McComb. I'm joined by building science expert Peter Yost and producer Jeff Rose. Peter consults and presents on building performance and building science matters. You can email your questions to fhbpodcast@taunton.com. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can also leave feedback and ask questions there too. Peter, it is such a pleasure to have you here. Thank you for agreeing to being on the podcast.
Well, it's my pleasure, Patrick and Jeff. It's have a long and very satisfactory relationship with Taunton Press and Fine Homebuilding. So
I love that you're still involved. It's awesome.
Me
so
too.
Are you healthy? Your family okay? Are you able to work?
Yeah, thanks for asking. Yeah, I have, I do a bunch of different things in my business. And so some work is pretty much on hold for the indefinite future, but about half my work is still cranking along. So I'm just shy of 65. And so I was thinking I'm going to work full-time this year till December 31st and then part-time next year. I think I'm going to be working part-time this year and full-time next year.
Yeah. So tell me, can you explain what you do for a living? Because you wear a lot of hats. So can you tell me what the various things you do are, please?
Yeah. So I teach and train, and some people say, well, what's the difference? So training, you say your piece, and it doesn't matter what you say because you're going to leave the next day. And the tough thing about teaching, like I teach a fall semester course at Yale on buildings, and then I am now teaching a spring course at Keene State for the Department of Architecture. And the difference with teaching is that, you're there for 14 weeks. So what you say one week has got to connect to what you say on the 10th week. So it's a whole different ballgame. And so I split my time between teaching and training. And then it's sort of similar when I do consulting, because if it's new buildings, I'm looking at design and spec review. And if it's existing buildings, I'm doing building investigations or building assessments.
So when they ask you to evaluate a new building or a planned building, what are you looking for specifically?
Yeah, that's a great question. So most of my work is hygrothermal. So it's looking at the way that heat and water moves in different expressions in, on, through buildings. So I'll be looking for control layer continuity, the water management, the air, thermal, and vapor.
Can I ask a dumb question?
Sure.
Shouldn't the architects who've designed this building have considered those things already?
Yeah. Okay. So right to the heart of it. People love to pick on architects, and it's not just the architectural profession, which has sort of an educational deficit when it comes to building science and building science principles. We're guilty across the board. I mean, I was a builder remodeler with several of my brothers. I have 10 brothers and sisters, and many of them have been involved in the construction industry. But we turned off our brains. We used to say multiple years of college down the drain because we still can't figure out how the water moves through the flashings. But we built pretty much the way my oldest brother's father-in-law built, and that was a guy named Joe Prue. He was like a 7th generation French Canadian framer, and you did it the way Joe told you how to do it. So we don't have much or enough education about building science principles, but it's not just architects. There's plenty enough lack of education, or if you want, I'm a Lutheran minister's son, guilt to go around.
Did your brother's father-in-law get it right through the many generations of training he had?
Yeah, so that's a good question too, because there's this tension between how we used to manage, particularly bulk water, before we had sticky stuff, right? And so before we had sticky stuff, or not that many, we had asphalt, liquefied asphalt. That was the sticky stuff. And so before we had a lot of polymers, we had to rely upon the way that materials uh, managed water in different ways, like stone compared to concrete. Stone is water impermeable, concrete's a porous sieve, um, and deflecting things. So without sticky stuff, you got to be really careful about how water moves over surfaces and off surfaces. Well, we get sticky stuff, and then we sort of turn our brains off, and then we say, "Oh, let's just let the sticky stuff do it." Now we can do, flush designs without any overhangs. And so, can you do a building that sheds water with with no overhangs and flush design? Yeah, it's just really a lot harder.
Mhm.
And now you're really dependent on sticky stuff. So, yeah, a lot of what Joe taught us made sense, but he thought that we were building the same way we were today compared to 100 years ago. And that's where we get into trouble, because the physics hasn't changed, but a lot of our materials have changed.
So what's the name of your company? And
Sure. Yeah. So I worked at Building Green here in Brattleboro for quite a while. I worked at Building Science Corporation, sort of in between, with Joe Stiebrick and Betsy Pettit. Um, just recently, I decided that I was getting old and cranky enough that I needed to be on my own. So I amicably left Building Green and started a company called Building Right, with right having a W in the front, sort of a play on words like,
a house right.
yeah, there's a house right, there's a mill right, there's a cart right. They're all people who have a craft related to the object, the cart or the mill, or in this case, the building. Um, so I thought it was incredibly clever. And but there was a guy in Australia that had buildingright.com with a W. So I had to put a hyphen in. And that hyphen just likes drive everybody absolutely crazy, including me.
Yes.
But anyway, I really like the name of the company. And yeah, so I'm a one-man band. And as my wife says, all the different hats is, playing to your attention deficit. So,
How did
seems
you
to
get
work.
into this crazy business?
Yeah, I was teaching high school in Hampton, New Hampshire, physics, chemistry, and biology. And in the summers, I was a grunt on my brother's job sites.
How old
And
were you?
the first year of teaching, I was 22, which was cool because I was teaching science, and I had one class where there were two 19-year-olds,
Yes.
one girl and one boy. And yeah, I was in either way under or over my head, one or the other. But in the summers, I got to work with my brothers, and after about 4 years of teaching full time, I just thought, my brothers. I don't love them all the time, but they're way more lovable than these teenagers are. So I actually continued to work kind of part time with my brothers, because I opened up a technical climbing school, and I described it as my self-unemployed era, because basically I just was really poor and was a rock jock. And then when I needed money, I went begging and screaming to one of my brother's job sites. But eventually, I became a full-time builder remodeler, and then I had a health problem that meant that I couldn't be a full-time carpenter anymore, and ended up back in school. So it was horrible to lose the trade, but
I've never heard anyone say that.
yeah, I was just lucky enough that I ended up back in school and still able to research buildings. So I sort of connected the two things that were never connected for me, which was academics and job sites. Um, and I stumbled across the National Association of Home Builders Research Center. I had no idea it even existed. And eventually got a job interview there and got paid to do all the stuff and read all the stuff that I fell asleep. When I was on a job site all day, I would take a copy of Fine Homebuilding or Journal Light Construction. and fall asleep reading it. And now I was getting paid to read that stuff and figure it out. So
you and your buddy Steve Basic present all over the country discussing building science principles. Can you tell me a little bit about those talks and who sponsors them and what folks get out of that?
Well, let me start by saying we try not to be disgusting, but sometimes when you put me and Steve in the same room, that's where it goes, you know.
I apologize for that.
No, it's probably a Freudian slip since you've already interviewed Steve. Yeah, you know, we met at Building Science Corporation, and Steve and I have very different backgrounds in many different ways, but we both love buildings, and, you know, we both are pretty tied to our families. And after we actually both left Building Science Corporation about the same time, and had a consulting firm with my brother Nathan, who also had worked at Building Science Corporation. But after that sort of period, Steve and I just continued to do a lot together. If he needed work with building science, he would call me. If I needed to find a really high performance architect, I would call Steve. Steve was on the editorial advisory board for Building Green and Environmental Building News. He was one of the first green building advisors when we developed that publication and online for Taunton Press.
So you still do a lot for them, right?
Yeah, I'm still technically the technical director for Green Building Advisor, and I do a once a month building science blog for that. But Steve's the one, you know, he called me up one day and he said, you know, I think we're going to be able to do some building science trainings through Huber. They're really interested in the intersection of the new codes and more airtightness and their new products that, you know, blend together structural panels and air and water management. And I thought, sure, Steve, you know, that sounds interesting. I gave it like no chance of ever happening, but he really stuck with it and worked with Huber. And one day out at IBS, International Builders Show, I met with a couple of people at Huber, and we were off and running with this home building crossroads, where the crossroads are where the codes and building science and high performance all sort of overlap. So that was 4 years ago. And, you know, we just keep adding more markets that we're going to. And, you know, we had a couple of requirements that it not be just the Huber show, and that they couldn't review our PowerPoints before we had to be sure that we, you know, didn't make non-building disgusting choices in our PowerPoints.
Right.
But yeah, and so we had a lot of autonomy. They said, if you're shills for us, it won't work. You know, people have to understand that your trainings are independent, even though they're sponsored by product manufacturers. And that was the other thing. We had to have a group of product manufacturers. It couldn't be just Huber. So when we worked all that out, you know, we're getting really good traction with both builders and architects for these trainings. And the focus is pretty much new construction. And we'd like to cover retrofit. We'd like to cover non-residential buildings, but there seems to be plenty of need in the single-family detached new construction world to get around. So it's a lot of fun. And
those are free for the participants, right?
Yeah, a lot of underwriting from the sponsors. We actually experimented with, you know, could we get a higher show up percentage if we charged a small fee? But the logistics are just too difficult, and it proved to be not a good way to try to, you know, you're just going to have a certain number of people that say, oh, for free, I can go. And then the day shows up and they're busy.
Right.
And, you know, we're very careful about time of year and the day that we pick. So we found that was way more influential than whether people pay it or not.
Can you tell me like your top 5 building diagnostic tools and what you use them for? That's a really deep question, I know, but if you could, that'd be great.
Yeah. So what's funny about this is that I'm teaching a brand new course at Keene State called Building Performance Assessment. And it's almost all architects. They're juniors and seniors. Peter Temple used to be the long-term building science professor at Keene State, a really wonderful guy who went to UMass Amherst and has a PhD in physics. But anyway, when he retired, they picked another old guy like me to stand in. And we developed this 4-credit course. And one of the things is the students will come out with either a level of awareness or actually some practical skills with a whole group of tools. And of course, the first one is a digital pressure gauge. That's a key part of a blower door, but there's actually a lot of ways you can use a digital pressure gauge to understand how buildings work beyond just its role in a blower door. Moisture meters, they can measure the moisture content of different building materials. And then hygrometers, which measure the moisture content of air masses. And I use Hobo data loggers quite a bit. They're interesting because a number of times when you go to do a building investigation, you're there for a snapshot. And you can't always figure out what's happened with a building by going and visiting it once. That snapshot may not be enough. So I would say about 30%, about a third of the building investigations I do, I give an initial assessment. Here's what I think is going on, but you have to let me leave some stuff behind to collect data. So Hobo data loggers collect information on moisture content, on
Temperature.
relative humidity and temperature. So sometimes you want to give the client what you think the solution or the problem identification and the solution are in 1 4-hour visit, but that's quite often not how simple it's going to be. Infrared camera, I use that quite a bit, both for and all of this is about trying to track the 3 ways that heat moves through a building and the 4 ways that water moves through a building. So it's neat because to me, when I was teaching physical science and physics in high school, I really liked, the investigation part of it. And now I just get to do that exclusively on buildings. So the physics, it's kind of funny because Steve will say, yeah, he's not Professor Yost. He's just a former high school teacher talking about science, But really the science is in some ways not all that complicated. It's just the way that the principles get expressed in buildings is complex and variable from building to building to climate. Yeah, so those are the basic tools. Although, funny that I'm wrapping up this course at Keene State and the campus is closed. So this 4-credit practical field course, halfway through the semester, we're online. So what the hell do we do? These kids were just learning how to use a lot of the tools. So what's interesting is a lot of them, their final project is assessing a building. For many of them, their home, because that's where they got sent. And they have no tools, right? So what are they doing? Eyes and ears and brain.
And smell.
Yeah, exactly. They don't have a blower door. They don't have access to an infrared camera. So it's kind of interesting that a lot of the building investigation stuff is visual inspection, and that's a lot of what they're accomplishing. Now, it'd be great if they could add to that, and some of them really are chafing at the bit, like, man, we were interested in learning the tools. So it's frustrating for them. It's frustrating for me, but there's an awful lot that's about tracking stuff with your brain and your eyes.
For the clients you consult with, both new projects and problem buildings, do you feel like they have any idea about building science? Do they have any understanding of the mechanisms that work in their buildings at all?
Yeah. So to be a little bit gentle, both builders and architects have a whole bunch of lenses through which they have to look at their project. And while essential, understanding how moisture and energy flows in, around, and through buildings is just one of the lenses. It's not one you can skip. So they've got an awful lot on their plate. But interestingly, from the high school level up through the graduate level, and I teach at all those levels from the local high school here in Brattleboro to their carpentry classes all the way to graduate school at Yale. Every single time the issue comes up of building science trainings, it's like the curriculum's already full. You can have an elective course, but we just don't have the time or the bandwidth. It's like you can't treat building science as an elective. So that's the underlying problem, is that while it's a topic that people recognize should be part of the mix, it's not treated as baseline, or everybody needs to know this.
That's interesting to me. Like if you could create the ideal curriculum, right, for architects, what would you take out of their traditional field of study to put more building science emphasis in its place? Could you spare something?
Yeah, wow, I'm going to get myself in hot water in a number of different ways with this one. So are there aspects of building performance that we could consider elective as opposed to essential? Yeah, that's a really tough one, because, even for interior designers, like, because I taught we developed a curriculum called Regreen when I was working with the U.S. Green Building Council while at Building Green. And we even found building science connections that interior designers needed to make. I like the way Steve approaches it. He says, look, when you ask me to design something, just tell me what your priorities and constraints are. Like if he had a client while we were at Building Science Corporation who said, okay, we build slab on grade. We always put the domestic hot water piping in the slab. One of our number one complaints is cooled hot water in the lines, so that they have to wait inordinately long to get hot water. And they said it's one of our number one customer complaints. You're going to now, they told Steve, you're going to now design all the homes so the maximum length of a domestic hot water run from the domestic water tank in the garage to any of the draws is 20 feet or less. Now, some architects would say, I can't do that. That's impossible. And Steve said, it's just another design constraint. All right, now you've told me I have to find the physical relationship between the bathrooms, the laundry room, the kitchen, and the hot water tank. Now, does that constrain my design? Yeah, it does. But I'm still a designer. I'm still creative. I can figure out different ways to design buildings with that as a constraint. It's just one more constraint. So I think, that's one of the things I love about Steve, is that he just takes whatever you give him and says, if you tell me I have to do this, I'll figure out a way to do that. But you have to help me prioritize, right? Because if hot water is an option, not a requirement, then I'm going to locate, the bathroom and what did we do in the olden days? We took all the draws for hot water and we stacked them and we put them in the center of the house. Why? Because copper was really expensive. And we had respect for the fact that, if in older New England homes, we would shut down outer buildings and gather around the hearth at the core. So of course you had to have the plumbing all in one place, because if you strung it out all over the place, it would freeze during the winter. Right. So, it's constraints. And sometimes the constraints are materials or money or layout. But if you look at them as constraints and prioritize them that way, it's just part of the design challenge.
What do you think the biggest issue facing residential construction is? And accepting the present craziness, but what are we getting wrong? What do we need to be doing better?
Well, one of my big lenses is the relationship between energy and moisture. And, my big mantra is you have to manage them with equal intensity. It's heat flow through buildings that dries them out. So if you reduce the heat flow through a building and you don't manage the moisture better, well, the moisture is going to stay in the materials longer, maybe long enough to cause a problem. So when I was a builder, it would have been so easy if someone had just walked up and said, you know what? Every time you reduce energy flow through an assembly, you better be managing the moisture better. like, oh, okay, that makes sense if it's the heat that's drying them out. So in the olden days, for example, this is a great example. In the olden days, in structural brick buildings, um, where were all of the radiators? Well, they were tucked right underneath these uninsulated brick walls. So all the water would run down the glass and accumulate at the sill. Well, that was okay because there were these big ass radiators there. And so where the moisture was gathering the most at the sill of the windows, that's right where the heat was. Okay, so now we come along and we're going to retrofit that building and we're going to say, oh, we're going to take out those radiators and put in a forced air system. Okay, so could you get the same amount of heat delivered to the space with a forced air system as the radiator? Yeah, but the forced air is not going to focus that energy right underneath that window. So a building that lasted 100 years with that radiator right underneath the window in a mass brick building, in 2 years it'll fail. The brick will start crumbling, and it's all because there's just not enough heat flowing there to overcome and dry out the moisture. So we've had these relationships in buildings all along. We just didn't have as much respect for them. And now that we're micromanaging the energy flow, we have to micromanage the moisture flow. Another example, wood frame buildings. Weatherization crew comes in and says, hey, for free, the federal government's going to, stuff your wall full of cellulose. Okay, so you're now going to go from an R of 1 in that wood wall to an R of, say, 13. If there's a little water leak underneath the window, for 100 years, that little water leak underneath the window may have not caused the problem. There was R1, there's all this heat flowing through, right? So you come in and you say, hey, we're from the Department of Energy. Our job is to stop the energy flow. We're going to stuff it full of cellulose. So after 100 years, you're not going to fail that wall in 2 years or less, because if you manage the energy better, you got to manage the moisture better. And it's that's the kernel around which I do all my work, because now it gets complicated. Well, how does energy flow? What are the different ways? How are the different ways that water flows? But that's the one big connection that everybody in the building industry needs to make. That's just not part of our makeup, and it needs to be.
Do you think that's an issue of training? Like, accepting your seminars with Steve, like how do people learn this stuff? Like where are they going to get this information?
Yeah. So, the internet is both a beautiful and a very scary thing, because, you can even as a layperson get yourself into a crap ton of trouble thinking that you understand because you've read, lots of free material on the internet. So it's both a wonderful resource, but it's funny. I have two clients I'm working with now. One is in Colorado and the other is in Los Angeles, and they are green builder and fine home building junkies. They're like, and they're finally working on building their own house or renovating their own house. And they start to do this stuff. And then I get a phone call saying, you know what, I'm just overwhelmed. I think I understand, but there's too much information rather than not enough information. So now I become the filter as opposed to the source, right? They're getting it all from somewhere, but it's how do I turn that wealth of information into the expression in a particular building?
And it's both the building and the client, right? I mean, it has to be custom tailored to the individual case, right?
Yeah. And, another mantra of mine is everybody needs adult supervision at some point, right? I mean, I get questions like, I don't know. And so there are people I call who are experts in particular area, because none of us can be expert in everything. So that's the other thing about working with Steve is, he comes across as not humble at all and very full of himself at times, but he really isn't. He is a very like, hey, I admit that there are some things that I need to go and get somebody to take a look at this for me because we can't all be experts in everything.
So quickly, before we run out of time, I'll let you pick the question to answer. You can either tell me about your house or the worst building science disaster you've ever seen. I know what listeners are going to want to hear.
What if they're the same thing? Like my house. Yeah. So we moved into this house in 2000, and it was just a dog.
It's a weird house, right? It's concrete block, right?
Yeah, it's concrete block on the first floor. It was built by masons, and get this, masons that when they got to the top of the first floor said, "Hey, let's build a 4-gabled gambrel roof assembly." Like pick the most complicated framing you could ever imagine, and it shows in their woodwork. That's for sure. But so that project was really cool because I got to do a room by room retrofit. But one of the lessons learned is, if you're trying to do continuity of management of air and water, room by room is absolutely not the way to do it. So to be comprehensive, you really need to, do a deep energy retrofit on the building as a whole. But, we couldn't afford to do that. We went after it room by room. So really cool project. There are several case studies on Green Building Advisor about my house and its retrofit. But what a blast to take what I had learned from, working at the Research Center, and Dan Cautley as my mentor there, and Joe Stiebrick as my mentor at Building Science Corporation, Chris Schumacher, Kota Ueno, all those guys, and figure it out. I remember Joe saying, "So you actually tried that thing I talked about on the outside of your building?"
I bet that's heartening.
Yeah, I was like, "Yeah, Joe, because you told me to do it that way." He said, "Okay, if it worked, that's great." So I'm most proud, I think, of both the good things and the mistakes I made on my own building.
Are you data logging it?
I've done a lot of data logging on the building over time, with regards to radon, with regards to moisture levels.
How's it doing?
Oh, yeah. I mean, I learn stuff all the time, but I still have floor joists that are in direct contact with masonry in my basement. And every spring, I'm right out there with my moisture meter checking to make sure that the way I've managed it works out. And that's the other thing about it, is it's sometimes, you have to admit that you have to get back into buildings to see if what you thought worked actually did. And that's scary for all of us in the building industry. Going, like, the last thing you want to do is to go back into something that you built, right? Because it's terrifying.
And especially if no one's saying it's a problem, why would you want to go look for problems, right?
Yeah, exactly. But you need to. You need to go back and see how past experiments are working out.
How about the worst building science disaster?
I think that the big nut to crack is that in all of our buildings that are high performance, we bury liquid sealants and pressure sensitive adhesive tapes that are relying on sticky stuff. And we're saying we're designing 100-year assemblies, but we are so dependent on those sticky things, and we can't inspect them, we can't repair them, we can't replace them, and they're buried inside our walls. So to me, that's not the biggest disaster, but it's the biggest thing that I worry about. And I spend a lot of time working on that.
That's interesting, because you're very old school in that approach, right? It's like that, like you're talking about your brother's father-in-law, who had been a builder for 7 generations, and he relied on gravity, and it kind of brings it full circle. Like that, maybe that's what we should be doing.
Well, we're asking an awful lot more of our buildings today. We have to ask more of ourselves. I think that's the disconnect, right? That, man, we're pushing our buildings to the absolute high performance, but the question is, are we keeping up with that demand? And I think that, like Home Building Crossroads is part of that effort. We have to ask as much of our building professionals as we're asking of our buildings, because if we're not, that's not fair. Yeah.
It's been awesome talking to you.
Hey, one more thing. You were going to ask me about who I would recommend to be on the show next.
Please.
So there's a guy named Peter Kulsick. He's a Minnesota building inspector. Great guy, and is really dedicated to high performance. So, there aren't that many code officials that I would recommend to be a great interview on your podcast, but you should try to talk to Peter.
I will do that. Peter, if you're listening, call's coming.
All right. So it would be Pete and repeat. You can tell him I said that.
Peter, it's been wonderful having you on the show.
Yeah, my pleasure.
Unfortunately, that's all the time we have today. Thanks to all of you for joining us. And thanks to Jeff for producing. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcasts. Thanks, everyone, for listening. Thanks, guys, for joining me. Stay safe, everybody. Happy building.